So today we are going to discuss May 2019 paper 3 Edexcel IAL Chemistry. Now let's move on to question number 1. The use of ammonium carbonate in smelling salt is due to the formation of ammonia which counters the effects that cause painting. When ammonium carbonate is heated gently, it decomposes to form ammonia, water and carbon dioxide. Write the equation for the decomposition of ammonium carbonate. Here they have given you the reactant as well as the product, so you just need to write a balanced chemical equation. Ammonium carbonate, and they have mentioned you it decomposes to form ammonia, water, and carbon dioxide. So you need to write the ammonia gas, carbon dioxide, and water. You need to write the state symbols as they have mentioned, it's not required. So just balance this equation. Move on to next question. Complete the table giving a chemical test. You need to write here the chemical test, not the indicators. Okay. So for the ammonia, what is the chemical test? Add hydrogen chloride. If you are writing the formula, so you must write the state here. And what you will see the white fumes, white smoke. For water, we can use anhydrous copper 2 sulfate. You know, the color of anhydrous copper 2 sulfate is white. And when water is added, what will happen? It becomes copper sulfate crystals and it becomes blue in color. And the test which you can use for water, you can write any one of the tests, is add anhydrous cobalt chloride. Cobalt 2 chloride. Its color will change from light blue to pink. Now, what is the test for carbon dioxide? Very common test. Add lime water, or you can write the saturated solution of calcium hydroxide. Calcium hydroxide is basically lime water. So lime water will turn milky, and why it turns milky? Due to the formation of calcium carbonate precipitates which are insoluble, so they form a milky solution. Now move on to question number 2. So what part 2 basically? Complete the diagram to show how you could collect the carbon dioxide obtained by heating ammonium carbonate using another test tube as the only additional product. So you need to collect the carbon dioxide, but you don't have any additional apparatus except the you have only the test tube. So here you can only use the test tube. So you can collect by using the test tube only. So you can draw the test tube as only a paper. Now, a sample of ammonium carbonate was dissolved in distilled water and the solution tested. Complete the table to give the expected observations and identify of the desired product. About 1 centimeter cube of barium chloride solution was added to 5 centimeter cube of ammonium carbonate. So when barium chloride will add into ammonium carbonate, it will form barium carbonate and ammonium chloride. So what you will observe basically, because barium carbonate is insoluble salt and the color is white, so you will observe white, and you will also observe that the precipitates form. So these will be the two observations. And what would be the product? It's the barium carbonate, and about 5 centimeter cube of hydrochloric acid was added to the mixture from 1. If you add hydrochloric acid into barium carbonate, because of the presence of carbonate, hydrochloric acid forms carbon dioxide gas. So you will see the bubbles of the gas fizzing, or bubbles or effervescences. And you will also see that the precipitates will dissolve because we didn't chloride will form, and the fizzing is due to the production of carbon dioxide. This is also question number one. Now move on to question number two. A group of students was asked to investigate with the liquid organic compound A. They were told that it was an alcohol with the molecular formula C4H10O. So the molecular formula shows that it's a butanol having 4 carbons. A chemical test may be used to confirm the presence of hydroxyl group in A. So first we need to test whether it's alcohol or not, confirm its presence of the hydroxyl OH group. A very simple test. You must remember this test. It's very important. It usually comes in the exams. So what is the suitable region for that? The phosphorus pentachloride. So you need to add PCl5. And what you will observe the misty fumes of HCl. Okay. Now move on to next question. A step student suggested that oxidation of A would help to identify it. The set of apparatus shown below were provided for the students to use. Identify the reagent mixture that can be used to oxidize A. So if you want to oxidize an alcohol, you need an oxidizing agent. So what is the best oxidizing agent for this? You can use potassium dichromate or sodium dichromate and along with sulfuric acid. Sulfuric acid is compulsory to write because it's of 1 mark. If you will not write sulfuric acid, you will not get any marks. So potassium dichromate in the presence of sulfuric acid. One student said if A was a primary alcohol, this could be shown by oxidizing it to the corresponding aldehyde and testing the product. Identify the separators 1, 2, or 3 should be used for this oxidation. You know the primary alcohols are first oxidized into aldehyde and they can further oxidize into carboxylic acid. So what do you suggest? Which apparatus is best for this? If you will look at all the apparatus, 3 apparatus, in the first one, there is a condenser attached. In the apparatus 2, condenser attached, but it's in the vertical position, the vapor will go upward and come back. And in the apparatus 3, there is no condenser. So in apparatus 1, if the aldehyde will be heated, if the alcohol is heated and it's oxidized to aldehyde, then it condenses and can be collected easily. So if you need aldehyde as a product and you don't require further oxidation into carboxylic acid, then apparatus 1 is the best one. So if you want to test the aldehyde as a product, so the apparatus 1 is best because the aldehyde, as soon as the aldehyde will form, it will be collected and the apparatus will prevent the further oxidation to carboxylic acid. So the ease of oxidation of the aldehyde and to prevent further oxidation into carboxylic acid. Otherwise, it will further oxidize and you will not get a positive test for the aldehyde. Now, next question, a chemical test may be used to confirm the presence of aldehyde. Identify the region used, giving the positive result of the test. So we have different tests to test the presence of aldehyde. We have Tollens reagent. You can use Spelling solution, Benedict solutions. So you can write any of the tests and its result. Like, but if you are writing a reagent, you must write its color. Like if you are using blue Spelling solution, it will turn red. If you are using the tolerance reagent, this is a variable form. For all the videos of the chemical test are available on my channel. Please go watch and subscribe. State whether or not positive result for the test in B3 together with the molecular formula would allow the alcohol to be identified. What do you think? It's only a positive test for the test B that its aldehyde is formed and molecular formula can identify the alcohol. Um, it's basically it cannot be identify its structure. It cannot be identify its name because with the same molecular formula and there can be two primary alcohols. So the positive test with the molecular formula is not enough only. So you can write the alcohol cannot be identified, and because there are two primary alcohols with the molecular formula C4H10O. The first alcohol can be this one, okay, and the second alcohol can be 2-methyl propane phenol, like this can be 2-methyl propane phenol. So both have this molecular formula. Both are primary alcohols, but both are different. So you cannot identify just by these tests. Now, another student said that if A was a secondary alcohol, this could be shown by oxidizing to the corresponding ketone. Yes, secondary alcohols are oxidized into ketones to identify which apparatus A1, 2, or 3 should be used for this. So now look at the apparatus. Now, if it's a ketone, which apparatus is best? Apparatus 2 is best because in apparatus 3 there is no condenser attached. In apparatus 2 condenser is attached. So as the alcohol will be oxidized to ketones and because ketones are organic compounds and volatile and if the vapors will go, so they will not be lost into the environment, they will condense that and come back into the flask. So apparatus 2 is the best one for this. And why? Because it will ensure complete oxidation. Now, in a further experiment, the student passes the vapor of A overheated aluminum oxide to form an alkene. Give two reasons for the use of mineral wool. Mineral wool, basically, what's the reason for mineral wool? Because the alcohol is soaked in mineral wool. So, basically, the mineral wool holds the alcohol. And what can be the other reason? Because the mineral wool is inert, is chemically inert. So we are using it because it will not react with alcohol. So the reason is that the mineral wool holds alcohol in place at the end of the tube. The alcohol vapors would not pass over the catalyst slowly enough to react, and the mineral wool is chemically inert, so it does not react with alcohol. These are the reasons. If the alcohol is soaked in the mineral wool, it slowly pass over the catalyst. Explain why it is necessary to remove the delivery tube from the heated tube immediately when heating stops. Okay, because what will happen? There is a possibility of suck back. So to avoid suck back, why? Because when you stop heating, so what will happen? The cooling takes place. On cooling, the pressure in the tube drops and atmospheric pressure acting water on water in the water bath in the water bath which causes a suckback, which causes basically a pressure difference and a suckback, which results in suckback, resulting in suckback. The alkene formed in C reacted with a small amount of bromine, giving a compound with the molecular formula C4H8Br2. State the color change when the alkene reacts with bromine. So when the alkene reacts with bromine, there is an addition reaction takes place. It will form on 2-dibromo. Alkene or butene will be converted into 1,2-dibromo butane. So basically the color of the bromine water is brown. So it changes from brown to colorless. This test is also used to identify the presence of double bond. The mass spectrum of C4H8Br2 had a pair of peaks at m over z 107 and m over z 109, and also peaks at m over z 79 and m over z 81 due to isotopes of bromine. One student suggested that these peaks showed that alcohol A must be butane 2-ol. Explain how these peaks support the student's suggestion. Yes. So, what do you think? Why these peaks suggest that the alcohol is butane 2-ol? Yes. So basically, if we identify the peaks, the 79 peak is due to the isotope of bromine 79, and well, bromine has two isotopes. Okay. So if the compound is C4H8Br2, and if it breaks in this way, then you can see a fragment. And if you check the m over z ratio of this fragment, so if this is bromine 79, then two carbons, four hydrogens, and one bromine. So the sum will be 1 107. And if we will take it as the bromine having the bromine isotope having the MR81, and if you will check, then the MR will come on 09. So if the peaks are showing at 107 and 109, it means the fragments break from this position. So it means that when the bond will break from here, so it shows the alcohol must be butane 2-ol. The OH group must be present at second carbon because the bromine is present here. So the only alcohol which can form but 2-ene as a product is butane 2-ol. Because this, when if you will look at the start of the question, this one says that the butane 2-ol is a secondary alcohol which can be converted into ketone, and then what happens that they convert that alcohol by passing its vapors to form alkene, and when alkene is formed, then bromine water is added to that, and it forms dibromo butane basically. So the alcohol initially was a secondary alcohol which was butane 2-ol. So the student that suggested that these peaks showed that alcohol A must be butane 2-ol is correct. So you need to write, you need to make both the fragments, these are of 1 mark. Then you need to show that how the peaks can come at 109 and 107, and then you can conclude your result that only butane 2-ol is the only alcohol that can form, but 2-ene as a product of hydration, dehydration, and only. So you can write that butane 2-ol is the alcohol that can form, but 2-ene as product of dehydration and only but 2-ene can form 2,3-dibromobutane. So you must write it's the only alcohol. So butane 2 is alcohol. So this is all for question number 2. Now for question number 3 and 4, watch the next video, the part 2 of the same paper. Stay tuned. Let's subscribe the channel and watch my videos. Thank you so much.